In this unit, we're going to use the properties of exponents to be able to rewrite numbers. From the last lesson, you learned that 2 to the 5th in expanded form would be multiplying 5 2's together to get 32. And if you had 2 to the negative 5, it would be like the reciprocal. It'd be 1/2 multiplied 5 times, and you would end up with 1/32. Again, do not use a calculator when you're creating these type. Just do 2 to the 5th and then create the reciprocal. The learning target for this lesson is I can rewrite numbers in the form in its lowest base with an exponent. So it's important to know some of the common bases and exponent forms of these numbers that we're going to be using throughout the lessons. So here are some tables to help you. We have the table of 2 raised to a power, and then 2 raised to the negative power. 3 raised to a power, 3 raised to a negative power. 4 raised to a power, and 4 raised to a negative power, and 5 raised to a power, and 5 raised to a negative power. Those are some reference tables that you can use for the future. Now today, what we then want to focus on after we do a little bit of review with exponent rules and making sure that you understand those, we're going to be solving exponential equations with common bases. What this means, if our base is exactly the same, then we can set our exponents equal to each other and solve. So the statement simply says the bases are the same and the exponents must be the same. So to solve them, we first have to make sure we have a common base. Once we have a common base, then we can set the exponents equal to each other. So for example, if we have 2 to the 3x power equals 1/16, we do not have the same base, but we can rewrite this with the same base looking back at our tables. So we have 2 to the 3x power equals 2 to the negative 4 power. Now that we have the same base of 2, we can set the exponents equal to each other and solve. So we have 3x equals negative 4, divide by 3 on both sides, and we get x to equal negative 4/3. We can check that by putting it back in for x and making sure that it works. Another example, we have 125 equals 5 to the x plus 6. Again, we can see we do not have the same base on each side. So let's rewrite the 125 as 5 cubed. We can use our tables again to figure out what that might be. Now we can set our exponents equal to each other. So we have 3 equals x plus 6. Move the constant to the other side and we end up with negative 3 equals x. Again, we can check to see if it works. So in this lesson, you are going to be rewriting numbers to a common base. You are going to be doing some checks to make sure you understand rules of exponents, and then you're going to be doing some solving of exponential equations. Just be sure your bases are the same before you start trying to solve, and then set those exponents equal to each other and solve. All right, good luck.